This is just a real quick video on the issue of the reason that, as I put in the description there, that you can see a jet or something going overhead that is small as it comes from one horizon and is at its biggest when it's over your head, and then it's small again at the other horizon. But the sun and moon don't seem to do that, because intuitively we might argue that the only reason that the sun and moon appear to rise and set is because of perspective, that just as in the same way that a jet approaching from one horizon to the other seems to be going up and then down. You know, as it goes away from you, especially, it seems like it's going down toward the ground, but we know it isn't. So why is it, though, that we might think that it's the same thing with the sun and moon, but the problem is they don't change size. Now, you could look at the sun and think, well, it's hard to tell the size because you'd have to have a filter, and which is easy enough to do, but you'd have to have a filter and make sure that the size hasn't changed. But it's a lot easier to do with the moon. I mean, especially moonrise, it seems, at least where I live, the moon is much larger on the horizon. So what happens to perspective then? And I think the key is whether you're under the sky or over it, in and under the sky, or between our atmosphere and wherever the sun and moon are. You can see here this drawing that I made from my earlier video challenging standard cosmology of the sun, that some sort of diverging lens is about the only way I can think of to explain, by the normal laws of physics and the physics of light, how the sun does what it does on a given day. So you might want to watch that if you're not sure what I'm talking about. But the thing is, it has an apparent position, an apparent motion that looks like the sun starts here, is pretty accurate to where it is when it's over our head, and then it goes here, meaning a north-south movement, or south-north if you're in the other south of the equator. So we have an actual movement of the sun and an apparent movement of the sun, and you could do the same with the moon, that I think is best explained with some sort of diverging lens, like a double concave. That this would explain the sun's north-south movement on a given day, that it can be both rising from one person's perspective and setting from another at the same time. This is not physically possible. Some people will try to solve the problem by making everything virtual and a hologram and a projection, but that, to me, is needless complication. You should look for the Occam's razor solution. And I think so far, the one that requires the least imagination and the least amount of guessing and the most amount of repeatable experiment is some kind of lens like this. So this, to me, explains that. But the problem is, the difference is that jets fly on our side of the lens. That's the point I'm trying to make. Okay. Jets fly on our side of the lens. I'm sorry, I didn't have my cursor where I thought it was when I was showing you motion on the sun here. We are under this lens on the blue box here, the blue surface. Okay. We're down here under this lens. And so are all the jets and the things that, birds, all sorts of things that go, clouds, they're all inside this bubble, basically. And, but the sun and moon are above it, in my opinion, in order to make this lens shape. And so the apparent motion of the sun or moon is a north-south motion that you can verify at any latitude. And time and date has been accurate as far as I can tell from my location, like I've said in my other video. The thing is that, again, physically, it's impossible for the sun to rise and set at the same time, because the person in, say, you're in this time zone, or you're in this time zone and the sun is setting, but for the person in this time zone, the sun, if you're in the southern hemisphere, if you're in the northern, it's the opposite. For one person in one time zone, the sun is setting, and the next time zone is rising. Not, precise. I'm just giving you the idea that the sun can't be doing that. So see my previous video on that. Sorry about the raspy morning voice. But the thing is that we can't write this off as perspective. Here's perspective, of course. as things go away from you, they appear to converge, whether it's above us and below us or side to side. They tend to meet at a spot in the middle. So that's perspective, and that applies within our Earth's surface and atmosphere. So things within our atmosphere on this side of the lens are going to behave as we would expect with perspective. But when we're dealing with something on the other side of the lens, that's not the case. So all that to say that the sun and moon don't appear to rise and set because of perspective. I don't think that's a good argument. I think instead what they do is just obeying the laws of the light, physics of light, and having an apparent position and an actual position. So they don't appear smaller because they're on the other side of a lens with a lot of, not distortion, but change in density between our viewpoints and where the actual objects are. So here again, I just don't think the perspective argument is a good one for sunrise and sunset, and the same for the moon. Not to say this is all completely solved, but I just don't think it's a good argument. Because like I said, we can observe that, at least it's easier to observe the size of the moon because you don't have to use a filter or anything. And anyone knows that at the horizon, the moon is way bigger than, it appears to be much bigger. So it can't be perspective. There has to be lensing. I know it's the trend of modern so-called science to say that, no, it's not lensing. It's just your eye. It's an optical illusion based upon the fact that there are things nearby the moon that make the moon appear bigger. And it's like that's the most ridiculous argument I've heard. It is lensing, but it's not necessarily the atmosphere. It's the difference in density between our atmosphere and whatever is between us and the sun and moon that have their own bubble of sorts, whether it's magnetic or whatever it is. It doesn't appear to be visible. And, it could be just, it makes most sense, of course, coming from an electric universe perspective, that there is almost always a magnetic field around things. And even if we haven't, if nobody's detected it, how would any of us know, what science so-called has done with their fancy equipment? But the point is, from our observations, I believe there has to be some kind of lensing, that this is probably caused by some kind of density around the Earth and the sun or moon, and that this is what causes north-south movement that shouldn't be possible, and that this also may help explain why the sun and moon don't appear to change size to smaller and to a pinpoint. See, if we take any other object under our atmosphere and watch it from one horizon to the next, when it's coming toward us, it's very tiny. When it's going away from us at the other perspective, at the other horizon, is very tiny. So the size changes, but again, that does not appear to be the case with the sun and moon. If anything, it gets smaller when it's near us, which doesn't make any sense if it's perspective. So it can't be perspective. And again, there's perspective, okay? This is not what we're observing of the sun and moon. So it can't explain the fact that, let me go back to that they seem to be like, say, look, this is a sunset. It appears to be going down toward the horizon. And we say, well, it's just perspective because it's just going away from us. But it should change size, not to bigger, to smaller. And that's not what it's doing. So I can only say that these things are far above us enough that that's not going to be the problem. And that the lens difference is why it appears to move north and south, but also why we can't just use perspective for this, because there's too many variables between us and the sun and moon. So I haven't answered anything, that's for sure. But what I'm saying is just that I don't think perspective is a good argument for why the sun and moon appear to rise and set. That's all I'm saying. Thanks for watching. Catch y'all later.